So guys, in this video we are going to see that how can we protect the colloids from that of your coagulation. So before going to that concept, I would just like to remind you that one of the point when we were distinguishing from that of your lyophilic to that of your lyophobic colloids. So there, when you see that distinguishment, of course I have mentioned there what your lyophilic colloids. Which one? Your lyophilic colloids are more stable. Lyophilic colloids are more stable when compared to that of your lyophobic colloids. Alva. So lyophobic colloids are less stable, and we have given a distinguishing statement over there. Phobic colloid are less stable. But now the question arises over here. What is that question? Of course, sir, when we were saying the stability of the colloid, you had just made us understand that the main scenario, the main criteria for the stability of the colloid is due to the presence of the similar charges on the surface of the colloidal particles. Alva. But now, when you're saying about that of your lyophilic and a lyophobic colloid, how can we say that your lyophilic is more stable and lyophobic is less stable? Yes, please do remember this. As we have said earlier, whatever the stability we are seeing, though it is less, but it is stable. Whatever the stability of the lyophobic colloid we are seeing, it is mainly because of the similar charges present on those colloidal particles. Similar charges present on those lyophobic colloidal particles. That is the reason it is somewhat stable. Okay. But when we are coming with respect to the lyophilic colloids, when the question arises that why it is more stable, remember it is having two important criteria. One is same as that of your lyophobic colloid, that is due to the presence of the similar charge. Due to the presence of the similar charge on the surface of the colloidal particles, which leads to that of your mutual repulsion, and that is the reason the colloidal particles are always in a motion. But the second most important criteria is what? Because whatever these lyophilic colloids are there, they are undergoing solvation. They are undergoing solvation and they have a solvent sheath around them. They have a solvent sheath around them. If I consider a lyophilic colloids, for example, in this way, so they are having one particular charge adsorbed on them. Yes, this is coming first criteria, having the similar charge. But when I am coming for the second criteria, we know that the lyophilic colloids are what? They are having the mutual interaction between the dispersed phase and the dispersion medium. So your dispersion medium, whatever it is there, it will be forming a protective layer. It will be forming another layer around this colloidal particles. So what is this another layer is actually? It is a surface layer. It is a surface layer of water of hydration. Surface layer of water of hydration. Why it is coming? Because whenever we are talking about a lyophilic colloid, here the dispersed phase will be a colloidal particles and dispersion medium will be a solvent. And due to their mutual interaction, what happens? Interaction, there is some sort of bonding tendencies existing between them. And due to that bonding tendency, what happens? That surface of your colloidal particles will once again be surrounded by a water of hydration. So this is the important criteria which is making your lyophilic colloids more stable than that of your lyophobic. Now when the question arises, in case if it arises for you, then why can't it form such a water of hydration can be formed in lyophobic? The answer is within you. Lyophobical kuda itara water of hydration yaki ondu layer agalla andre? Yes, because in the lyophobic colloids, the dispersed phase and the dispersed medium, there is no interaction is existing between them. Why? Because there is no interaction exists between that of your dispersed phase and the dispersion medium. Whatever we are lyophobic colloid, whenever we are seeing, it will be just be having one particular charge surrounding it. That is the reason it is somewhat stable, no problem. But when you are seeing for a lyophilic colloid, Of course, it is having one preferential adsorption of ion. Along with that, it is also covered by a surface layer of water of hydration. Why this surface layer of water of hydration is coming? Because of the mutual interaction of your dispersed phase and that of your dispersed medium particles. But now when the question arises, remember whatever we saw, the coagulation, that is by boiling, by the persistent dialysis, that was all with respect to that of your lyophobic salts. And we also mentioned over there. Now the question arises, okay sir, is there a possibility to coagulate your lyophobic colloids? Of course yes. So what is the reason or what is the tendency we have to do? As I have said when I was dealing with the lyophobic, if I am removing this charges which is adsorbed on the colloidal particles, of course I can coagulate my colloidal particles. The same scenario is over here. But here it includes the two important steps. What are those steps? First and the foremost thing, whatever the electrolyte I am adding, it should come and interact with that of your adsorbed ions. But it has to, whenever I am adding my electrolyte for that of your lyophilic colloid, what happens? It will be not be allowed. Whatever your electrolyte will be there, it is not allowed to interact with that of your adsorbed ion. Why? Because whatever the surface layer is over here of water of hydration, it acts as a security guard. So it will not allow this electrolyte. So first tendency what I have to do in order to coagulate my lyophilic colloids, I have to remove this water of hydration. So how can I remove it? Basically by utilizing some suitable solvent. ಯಾವುದು ಸಾಲ್ವೆಂಟ್ ನ ಯೂಸ್ ಮಾಡಬಹುದು? ಸೂಟೇಬಲ್ ಸಾಲ್ವೆಂಟ್ ಅಂದ್ರೆ ಬೇಸಿಕಲಿ ಇಟ್ ಈಸ್ ಯೋರ್ ಆಲ್ಕೋಹಾಲ್ ಆರ್ ಅಸಿಟೋನ್. Alcohol or acetone. Alcohol and we should say alcohol and acetone. So what it actually does is basically it dehydrates. So what it does, it dehydrates your water of hydration. It dehydrates that of your, and ಏನಂತ ಅರ್ಥ dehydrates ಅಂದ್ರೆ it will be just extracting out this surface layer. Or in simple words, what it is doing, it is dehydrating your colloidal particles or a dispersed phase. Alva, because it is having the water. So ಇದನ್ನ ಏನ್ ಮಾಡುತ್ತೆ, colloidal particles ನ ಅದೇನ್ ಮಾಡುತ್ತೆ ಅಥವಾ ನಿಮ್ಮ dispersed phase ನ ಏನ್ ಮಾಡುತ್ತೆ, dehydrate ಮಾಡುತ್ತೆ. So when such dehydration occurs, what happens? This layer has been removed. Then by the addition of electrolyte, what happens? Your mutual coagulation takes place. So this is a technique of your coagulation of your lyophilic colloids. Of course, lyophobic we have seen many. It was a simple task. Just by the addition of electrolyte, we have seen that your coagulation takes place. But when we come with respect to the lyophilic colloids, what is happening? There are two important tendencies we have to follow, or the steps we have to follow. First and the foremost thing, we have to dehydrate, or we have to remove this surface layer of water of hydration which is surrounding your lyophilic colloidal particles, and then you have to add your electrolyte. So from this concept, one important thing which strikes to our brain is what? Yes, lyophilic colloids are more stable when compared to that of your lyophobic colloids. Alva, when compared to that of lyophobic colloids. So utilizing now this concept, we are going to see that how can we protect our lyophobic colloid from that of your action of electrolytes. In simple words, I will be saying, using now this concept, that is the concept of the stability of lyophilic colloid, now we are going to see that how can we protect the lyophobic colloids from being coagulation. Okay, so under the concept called as that of your protective colloid. Remember guys, very much important topic now we are going to study in this over here is what? How can we protect our lyophobic colloids from undergoing your coagulation? Hagare artha enu? Whenever I am choosing my lyophobic colloid and I am adding an electrolyte, what should happen under this concept? The electrolyte should not come near your colloidal particles, your lyophobic colloidal particles, and coagulation should not occur. Hagadre artha enu? Even in the presence of the electrolyte, even in the presence of the electrolyte, the lyophobic colloidal particles should not get precipitated. What is the concept? Even in the presence of electrolytes, what should happen? Your lyophobic colloidal particles should not get precipitated. So how can we do this? By utilizing the concept of the stability of your lyophilic colloid. So basically, remember, your lyophilic colloids are called as a protective colloid. What it is called as? Your lyophilic colloids are called as protective colloids. Called as protective colloids. So what is doing? ಹೆಸರಲ್ಲೇ ಹೇಳ್ತಾ ಉಂಟು ಏನು ಮಾಡುತ್ತೆ ಅಂದ್ರೆ basically. So before the addition of electrolyte, what we are having, we are on our system, I would be having my lyophobic colloidal particles. ಏನಿರುತ್ತೆ first to lyophobic colloidal particles. So in that system, before the addition of electrolyte, what I will do, I will add some amount of that of your lyophilic colloid. Lyophilic colloid. So when I add this lyophilic colloid, what happens? This lyophilic colloids, now it forms a one protective layer around this lyophobic colloids. ಏನ್ ಮಾಡ್ತಾ ಉಂಟು? Your lyophilic colloid is having a tendency, or it is having a property such a way that it forms another layer around your surrounding your lyophobic colloid. So when such thing happens, what happens? When you are adding just electrolyte, remember, when you are adding just electrolyte, now what should happen? This electrolyte will not come in the contact of your lyophilic colloid. In turn, it is going to come in the contact of your lyophilic colloid. Alva? E electrolyte, whatever we are adding, it will not be coming in the contact of your lyophobic colloid. Instead, now it is coming in the contact of your lyophilic colloid. And we know what? In order to cause the coagulation of your lyophilic colloid, first we have to remove the layer which is surrounding your lyophilic colloid. And that is done by utilizing your alcohol and acetone. But I am not adding that part. So what happens? Even when we are adding the electrolyte, of course this electrolyte can't come near that of your lyophilic colloids. So when it cannot come near the lyophilic colloid, what happens? Our lyophobic colloids will remain as such. Alva? Will remain as such. So that reason what happens, whatever the colloidal particles dimension will be there, it will be same and it will be moving in the same kinetic motion without getting coagulated. So that is the reason your lyophilic colloids are called as what? Protective colloids. ಆ ಒಂದು ರೀಸನ್ ಇಂದನೇ ನಾವೇನಂತ ಹೇಳೋದು, your lyophilic, remember I am mentioning again and again, lyophilic colloids are called as a protective colloids. Why it is called as a protective colloids? Because when these lyophilic colloids are added, they are protecting the lyophobic colloids. Whenever these lyophilic colloids are added, what they are doing? They are protecting the lyophobic colloids. How they are protecting? By forming a protective layer around that of your lyophobic colloid. Even the layer ಹಾಕದ್ ಏನಕ್ಕೆ ಅಂದ್ರೆ, even when you are adding the electrolyte, it should not come and remove the charges of your lyophobic colloid. When charges are retained, what happens? Of course, the colloidal particles will be in their continuous random motion. And when they are moving, of course, they are in the stable condition and they are not going to get precipitated. So this is the concept one has to know when we are dealing with that of your protective colloid. So one very much important question, which colloid or among lyophilic and lyophobic colloid, which one is called as that of your protective colloid? And the kedadre, remember, it is your lyophilic colloid. Why lyophilic colloid? Because it forms a protective layer around that of your lyophobic colloid. So when such a protective layer is formed, what happens? On the addition of electrolyte, that electrolyte can't cause the coagulation or the precipitation of your lyophobic colloids. Is that clear? But now the question arises, okay, so we are having many such lyophobic colloids. Alva, it could be your starch, it could be your gelatin, it could be your hemoglobin. So all are the examples of that of your what? Lyophobic colloids. Then now the question arises that how much amount we have to put? ಅಲ್ವಾ. ಆಸ್ ವಿ ಹ್ಯಾವ್ ಸೀನ್ ಇನ್ ಅವರ್ ಅರ್ಲಿಯರ್ ವಿಡಿಯೋಸ್ ಆಲ್ಸೋ, ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ಅಲ್ಲಿ ಕೂಡ ನಾವು ನೋಡಿದ್ವಿ ಯಾವ ಒಂದು ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ಹಾಕಿದ್ರೆ ನಮಗೆ ಅಂದ್ರೆ ತುಂಬಾನೇ ಅತಿ ವೇಗವಾಗಿ ಕೋಆಗುಲೇಷನ್ ಆಗುತ್ತೆ ಅನ್ನೋದು ನಮಗೆ ಹಾರ್ಡಿ ಸ್ಕೂಲ್ಸ್ ರೂಲ್ ಪ್ರಕಾರ ಗೊತ್ತಾಯ್ತು. ವೇಲೆನ್ಸಿ ಯಾವುದು ಜಾಸ್ತಿ ಇರುತ್ತೆ ಬೇಗ ಕೋಆಗುಲೇಷನ್ ಆಗುತ್ತೆ. ಓಕೆ, ಅದನ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡೋಕೆ ನಾವು ಕೋಆಗುಲೇಷನ್ ವ್ಯಾಲ್ಯೂನ ಕಂಡಿದ್ವಿ. ಹಾಗಾದ್ರೆ ಈಗ ಒಂದು ಈ ಕಾನ್ಸೆಪ್ಟ್ ನ ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು ಅಂದ್ರೆ ಇಲ್ಲೂ ಕೂಡ ಒಂದು ಕಾನ್ಸೆಪ್ಟ್ ಬೇಕು ಅಲ್ವಾ. ಬಿಕಾಸ್ ದೇರ್ ಆರ್ ಮೆನಿ ಸಚ್ lyophilic colloids are present. Lyophilic colloids, many are such lyophilic colloids are present. It could be your starch, it could be your hemoglobin. Other lyophilic colloids, many are present. Now when the question arises that how much amount of this lyophilic colloid has to be added in order to protect that of your lyophobic colloid from coagulation, an important concept was known which is called as gold number. Very much important for your competitive exams once again. Gold number. Yes. So now let us understand what do you mean by this gold number. Remember, it is the number in milligrams. It is the number in milligrams of the protective colloid required. Number in milligrams of the protective colloid required. Protective colloid required. Yes, number in milligrams of the protective colloid required just to prevent the coagulation of 10 ml of standard gold sol, 10 ml of standard gold sol on addition of 1%, on addition of 1 ml of 10%, 1 ml of 10% NaCl solution. So what your gold number is saying? So basically it is the number in milligrams. Very much important it is. So gold number is what? It is the number in milligrams of the protective colloid. ಹಾಗಾದ್ರೆ ಆ protective colloid ಯಾವುದಾಗಿರುತ್ತೆ? ನಮ್ಮ lyophilic colloid. So it is a number in the milligram of the protective colloid which is required. Why it is required? To prevent the coagulation of 10 ml of your standard gold sol. So this is our lyophobic colloid. 10 ml of your standard gold sol. So yadrinda prevent ಮಾಡಬೇಕು? When you are adding an electrolyte, which is that electrolyte? NaCl. How much you are adding? 1 ml of 10% NaCl solution. So this is called as your gold number. So each and every lyophilic colloids are having their respective gold numbers. For example, if I take as it of your starch, so it is having the gold numbers of 20 to 25. Similarly, in the case of your albumin, which is also a lyophilic colloid, it is having the range of 0.1 to 0.2. Similarly, when I come with respect to the hemoglobin, so it is having the range of nearly 0.03 to that of your 0.07, and that of your gelatin. If I come, so gelatinic bandaga, basically it is having in the range of 0.005 to that of your 0.001. So these are some of the gold numbers. ಅಂದ್ರೆ ಪ್ರತಿಯೊಂದು lyophilic colloids they are having their respective gold numbers. So how they have calculated this gold number is very much important. So basically what is this gold number? It is the milligrams. It is the number in milligrams. And how did they obtain it? Of course they took a 10 ml of a standard gold salt solution. Okay, they have taken what? 10 ml of a standard gold salt solution. So to this one what they did, they have added 120 to 25 milligrams of starch. When I'm particularly saying about 20 to 25 range, they have added what? 20 to 25 milligrams of starch. Okay. So first thing your gold particles are present over here, which is what your lyophobic colloids. So to this one, what they did, they have added 20 to 25 milligrams of starch. So afterwards, what they did, then they have added 1 ml of 10% NaCl solution. So of course, what did they observe? The colloidal particles are moving. Alva. So when it is moving, when you have added the starch, in case if I have not added the starch, what would have happened? Of course, protective layer would have not been formed. So your gold coming with contact with that of the added electrolyte NaCl, it has been coagulated. But when I am adding a starch of nearly 20 to 25 milligrams, what did I observe? It is not undergoing coagulation. So this number, whatever I have added, alva, the lyophilic colloid, so that number in milligrams is called as what? Your starch. And I have maintained a specific condition. What is that? 10 ml of gold salt, standard gold salt, and 1 ml of 10% NaCl. So this is a specific condition I have to maintain. So in order I should get a proper gold number values. Similarly, when I am seeing for albumin, condition is same, but how much I have to add? Just 0.1 to 0.2. You can just see the difference. When I want to add my starch, in order to prevent the coagulation of your lyophobic colloids, I have to add 20 to 25 milligrams of it. But when I am coming with respect to the albumin, see how much I am adding? 0.1 to 0.2. That's it. Coming with respect to the hemoglobin, 0.03 to 0.07. That much it's. But coming to that of your gelatin, very much smaller, that is 0.005 to that of your 0.001. Now the concept arises is very much important. That is, how is your gold number is related to that of its protective power. Alva, how your gold number is related to that of your protective power. Remember guys, your gold number is inversely proportional to that of your protective power. Inversely proportional to that of your protective power. If the gold number value is very high, its tendency to protect the lyophobic colloids is very, very less. Able to understand that we have seen in the starch also. So when I was talking about the starch, so it is 20 to 25. That means what? I have maintained a standard solution for all the things. If I am taking starch, if I am taking albumin, hemoglobin, gelatin, all the cases, what is my colloidal range? It is at 10 ml of a standard gold salt. I am not changing anything. 10 ml of the standard gold salt means how much? 0.0058% of your gold will be present. 0.0058% of your gold will be present. So I have maintained the same condition. I have not changed anything. And whatever the electrolyte I am adding, what is it? Of course, it is also 1 ml of 10% NaCl. Whatever I am changing, it is with respect to that of your added lyophilic colloid. Alva. So here itself you are going to get whatever the gold number 20 to 25 we are getting. What does it mean? It is the number in milligrams of the protective colloid required. See how much it is requiring, very high. But when I am coming for the gelatin, can you see? Very small, 0.005. So solpa hakadre saku, a colloidal particles will get protected and they will not cause coagulation. Able to relate? So the same concept I have given a mathematical term. Gold number will be inversely proportional to that of your protective power. Is that okay? So very high gold number means what? That particular lyophobic colloid, that particular lyophilic colloid will be having the very less tendency to protect that of your lyophobic colloid. But in case if you are having a very least gold number, as in the case of a gelatin, that means what? That particular lyophilic colloid which is having a greater tendency to protect your lyophobic colloid. And the major example is that of your gelatin. So now when the question arises that you have to arrange the starch, albumin, hemoglobin and that of your, what you can say, next which one we are, gelatin. according to their protective power. How can we do it? Of course, alwa, first will be your gelatin, which will be having the highest protective power because it is having the least gold number. Then coming to the concept of your hemoglobin, which is after it. Yes, next will be your hemoglobin. And then you will be having your albumin. Then you will be having your starch. Alva. So this is when according to your protective power. First is a ಸ್ವಲ್ಪ ಜಿಲಾಟಿನ್ ಹಾಕಿದ್ರೆ ಸಾಕು ಓವರ್ ಆಲ್ ಕೊಲಾಯ್ಡಲ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಏನಾಗುತ್ತೆ ಪ್ರೊಟೆಕ್ಟ್ ಆಗಿಬಿಡುತ್ತೆ. ಆದ್ರೆ ತುಂಬಾ ಜಾಸ್ತಿ ಅದು ಬೇಕಿರೋದು ಸ್ಟಾರ್ಚ್ ಗೆ. ಬಟ್ ಇಫ್ ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಅರೇಂಜ್ ದೆಮ್ ಅಕಾರ್ಡಿಂಗ್ ಟು ದ ಗೋಲ್ಡ್ ನಂಬರ್, ವೈಸ್ ವರ್ಸಾ. Starch will be the highest, then albumin, then hemoglobin, then gelatin. But whatever I have written over here, it is with respect to their protective power. Why is it so? Because your gold number is inversely proportional to that of your protective power. Very much important concept. According to this gold number, of course, one question will going to arise in your competitive exam. So you have to understand in a better way. What do you mean by gold number? It is the number in milligrams. It is the number in milligrams. Gold number of a protective colloid will be defined as how? The number of milligrams of the protective colloid required, yes, just to prevent the coagulation of how much? 10 ml of your standard gold salt. ಯಾಕೆ ಇದನ್ನ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಗೋಲ್ಡ್ ಸೋಲ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ಗೊತ್ತು ನಮಗೆ. ಯಾವುದೇ ನಾನು ತಗೊಂಡ್ರು ಕೂಡ ನನ್ನ ಸಿಸ್ಟಮ್ ಅಲ್ಲಿ ನಾ ಯಾವ ತರದ್ದು ಚೇಂಜ್ ಮಾಡ್ತಾ ಇಲ್ಲ. ಸಿಸ್ಟಮ್ ಇಲ್ಲ ರೇಂಜ್ ಸೇಮೇ ಉಂಟು. ಆ ಸೇಮ್ ರೇಂಜಿಗೆ ಎಷ್ಟು ನನ್ನ ಲಯೋಫಿಲಿಕ್ ಕೊಲಾಯ್ಡ್ ನ ಆಡ್ ಮಾಡಬೇಕು ಅಂತ ನನಗೆ ಕರೆಕ್ಟ್ ಆಗಿ ಗೊತ್ತಾಗಕ್ ನಾ ಏನ್ ಮಾಡಿದೀನಿ, ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಗೋಲ್ಡ್ ಸಾಲ್ ನ ಪ್ರಿಪೇರ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀನಿ. ಎಸ್, ಆಮೇಲೆ ಅದಕ್ಕೆ ನಾನು ಏನ್ ಮಾಡ್ತಿದ್ದೀನಿ, ಐ ಹ್ಯಾವ್ ಆಡೆಡ್ ಅನ್ ಈಕ್ವಲ್ ಅಮೌಂಟ್. ವಾಟ್ ವಾಸ್ ದಟ್? 1 ml of 10% of NaCl solution. This is what standard condition I have maintained. Whatever I am going to change is what? Only the value of my lyophilic colloids. Yes. So by this way we came to the concept what? Gold number will give us the idea that how much amount of the lyophilic colloid has to be added in order to prevent the coagulation of your lyophobic colloids under the addition of your electrolytes. But now one thing is scratching my head. I don't know how much in your brain it is scratching. Of course, sir, if I am the first person who is doing for this starch, I am the first person who is going through this analysis of the protective colloid. And now my question is whether I have to do in all the trials. First I have to put 1 gram and I have to see, okay, colloid aita, oh agila. Again I have to put 2 gram and I have to wait. Colloid aita, coagulate aita, oh agila. 3 grams, 4 grams, 5 grams. It is something a hectic work, alva. Starch ನೋಡಿ nearly 20 to 25 milligrams ಹಾಕಬೇಕು ಅಂದ್ರೆ ನಮಗೆ ಗೊತ್ತಿಲ್ಲ. ನಾವು ಫಸ್ಟ್ ಏನ್ ಮಾಡಿದ್ವಿ 0.001 milligram ಆಗ್ಲಿಲ್ಲ. ಓಕೆ 0.05 ಹಾಕೋಣ ಆಗ್ಲಿಲ್ಲ. 1 ಹಾಕೋಣ, ಅಯ್ಯೋ ಆಗ್ಲಿಲ್ಲ. 1.5 ಹಾಕೋಣ ಆಗ್ಲಿಲ್ಲ. ಅಯ್ಯೋ ಇನ್ನು ಎಷ್ಟು ಹೋಗ್ಬೇಕು ನಾನು? much more we have to go. So in order to avoid such things, we need a formula for it. ಅಲ್ವಾ? ಡೈರೆಕ್ಟ್ ಆಗಿ ಫಾರ್ಮುಲಾ ಹಾಕಿದ ಕೂಡಲೇ what it should get, I should get the gold number ಅಥವಾ ಎಷ್ಟು ml ಅದೆಲ್ಲ ನಮಗೆ ಗೊತ್ತಾಗ್ಬಿಡ್ಬೇಕು, ಎಷ್ಟು milligrams ನ ಹಾಕಬೇಕು. So how to extract that formula or how to calculate from those formula, let us see by solving certain important problems. So guys, as we have seen what do you mean by that of your gold number in that of what definition part, now we will be able to see what is the formula for gold number. Of course this is not going to get asked in your PU board exam, but this is very much important concept for your competitive exams. So coming to the definition of your gold number, yeah, what is the formula? Basically remember, it is the number of milligrams of lyophilic colloidal salt added. I repeat, gold number equals number of milligrams. This is very much important. Number of milligrams of what? What you are adding as a protective colloid? Lyophilic alva. Number of milligrams of your lyophilic colloidal salt added divided by volume of solution in ml into 10. Very much important. Into 10. Why 10? Because whatever the gold salt we have taken is how much ml? 10 ml only we have taken. That is the reason. Once again I repeat, gold number equals number of milligrams of lyophilic colloid salt added divided by volume of solution in ml into 10. Very much important. So depending upon this formula, now let us see how to calculate your milligram value or how to calculate that of your gold number. So first important question, what they have done, okay, they have said as gold number of hemoglobin is 0.03. ಓಕೆ ಒಂದು ಡೇಟಾ ಕೊಟ್ಟಿದ್ದಾರೆ, ಏನು ಗೋಲ್ಡ್ ನಂಬರ್ ಮೊದಲೇ ಕೊಟ್ಟಾಗಿದೆ. ಹಿಮೋಗ್ಲೋಬಿನ್ ಗೋಲ್ಡ್ ನಂಬರ್ ಯಾವತ್ತೇ ಬರೆಯೋದು ನಾವು ಯಾವುದಕ್ಕೆ, ಲಯೋಫಿಲಿಕ್ ಕೊಲಾಯ್ಡ್ಗೆ. ರಿಮೆಂಬರ್, ಶುಡ್ ಬಿ ಕೆಪ್ಟ್ ಇನ್ ಯೋರ್ ಮೈಂಡ್. ಯಾಕೆ, ಬಿಕಾಸ್ ಲಯೋಫಿಲಿಕ್ ಕೊಲಾಯ್ಡ್ ಇಟ್ ಸೆಲ್ಫ್ ಇಸ್ ಅ ಪ್ರೊಟೆಕ್ಟಿವ್ ಕೊಲಾಯ್ಡ್, ಲಯೋಫೋಬಿಕ್ ಅಲ್ಲ. ಸೊ ಗೋಲ್ಡ್ ನಂಬರ್ ಆಫ್ ಅ ಹಿಮೋಗ್ಲೋಬಿನ್ ಮೀನ್ಸ್ ವಾಟ್, ಇಟ್ ಶುಡ್ ಕಮ್ ಟು ಯುವರ್ ಮೈಂಡ್. ಕ್ವಶನ್ ಓದ್ಕೊಳ್ಳಿ, ನೀವು ಇನ್ನೊಂದೊಂದು ಆನ್ಸರ್ ಮೈಂಡಿಗೆ ತಗೋಬರ್ಬೇಕೇನು. ಓಕೆ, ಹಿಮೋಗ್ಲೋಬಿನ್ ಇಸ್ ಆಲ್ಸೋ ಅ ಲಯೋಫಿಲಿಕ್ ಕೊಲಾಯ್ಡ್. So gold number of hemoglobin is what, 0.03. Yes, hence 100 ml of the gold sol will require 100 ml of the gold sol will require hemoglobin so that gold is not coagulated. ಕೇಳ್ತಿರೋದೇನು ಅಂದ್ರೆ basically the question is somewhat they have twisted it. So they are asking that how much milligrams of the hemoglobin is required, how much milligrams of your hemoglobin is required to coagulate 100 ml of your gold sol, 100 ml of your gold sol, so that gold is not coagulated. This is their question. 100 ml of the gold sol na coagulate ಮಾಡಕ್ಕೆ ಎಷ್ಟು milligram of hemoglobin is required when the gold number of the hemoglobin is given. So this is your question. Okay, let us go with the formula. Gold number ಉಂಟಾ, ಉಂಟು. ನಾವು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕಿರೋದೇನು, ನಂಬರ್ ಆಫ್ ದಿ ಮಿಲಿಗ್ರಾಮ್ಸ್ ಆಫ್ ದಿ ಹಿಮೋಗ್ಲೋಬಿನ್. ಲಯೋಫಿಲಿಕ್ ಕೊಲಾಯ್ಡ್ ಇಲ್ಲಿ ಯಾವುದು, ಹಿಮೋಗ್ಲೋಬಿನ್. ಸೊ ಇದನ್ನ ನಾನು ಏನಾದ್ರು ತಗೊಂತೀನಿ, ಲೆಟ್ ಮಿ ಟೇಕ್ ಇಟ್ ಆಸ್ ಎಕ್ಸ್. ಸೊ ವಾಲ್ಯೂಮ್ ಆಫ್ ದಿ ಸೊಲ್ಯೂಷನ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಎಷ್ಟು, ಇಟ್ ಇಸ್ 100 ml. ಓಕೆ, 100. ಸೊ ಇಂಟು 10 ಅಲ್ವಾ, ಸಿಂಪಲ್. 0.03 ಇಂಟು 100 ಡಿವೈಡೆಡ್ ಬೈ 10. ಆಫ್ ಕೋರ್ಸ್ 0.03 ಅಂದ್ರೆ ಅರ್ಥ 3 ಬರುತ್ತೆ, 3 ಡಿವೈಡೆಡ್ ಬೈ 10 ಮಾಡಿ, ಅಥವಾ ಡೈರೆಕ್ಟ್ ಆಗಿ 1 0 ಕ್ಯಾನ್ಸಲ್ ಮಾಡಿ. Into 10 means 1 point shift ಆಗುತ್ತೆ. So whatever the x value we are going to get is how much, 0.3 milligrams. Able to see 0.3 milligrams. Very much important. So ಅರ್ಥ ಏನಿದ್ರದ್ದು 0.3 milligrams ಅಂದ್ರೆ, yes. So ಇಲ್ಲಿ ನಾವು ಯಾವುದಕ್ಕೀಗ ಹಾಕ್ಬೋದು, 0.3 milligrams. So what does it mean? 0.3 milligrams of your hemoglobin is required. 0.3 milligrams of your hemoglobin is required for what? In order to coagulate your 100 ml of your gold sol when you are adding 10 ml of your 10% NaCl solution. Able to understand? Very much important. You have to analyze your answer also. What is the value, whatever value you have got, what it is want to say, in order to coagulate your 100 ml of your gold sol, yes, when you are adding a 10 ml of 10% NaCl solution, we require 0.3 milligrams of your hemoglobin in order to protect our gold sol. Alva? So this is the scenario. Can you see how much easily we can calculate? Now let us do a calculation for our gold number also. Okay, we are seeing what in our experiment, the coagulation of a 100 ml of the colloidal solution of gold is completely prevented. Okay, they have only prevented, very good, by the addition of what, 0.25 gram of starch. 0.25 gram of starch. Okay, 100 ml gold sol na coagulate ಆಗದೇನೆ ಪ್ರಿವೆಂಟ್ ಮಾಡಕ್ಕೆ ಏನ್ ಮಾಡಿದ್ದಾರೆ ಅವರು, 0.25 gram of starch ನ ಹಾಕಿದ್ದಾರೆ. Very good. Before adding 1 ml of 10% NaCl solution. Okay. So 1 ml of 10% ಅಂದ್ರೆ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ಹಾಕಕ್ಕಿಂತ ಮೊದಲು ಏನ್ ಮಾಡಿದ್ರು ಅವರು, 100 ml colloidal solution coagulate ಆಗಬಾರ್ದು ಅಂತ ಹೇಳಿ 0.25 gram of starch ನ ಹಾಕ್ಬಿಟ್ಟಿದ್ದಾರೆ. And they have asked to calculate our gold number. Let us do it. So of course, what is the gold number is equals to number of milligrams of your lyophilic colloidal sol required. But ಆದ್ರೆ ಇಲ್ಲೇನ್ ಮಾಡಿದ್ದಾರೆ, they have given us the tendency in grams. Very much important. You should be very much particular about your units also. See, I just wanted to mention one more important thing. See your options, how much close they are, 0.03, 30, 0.303. ಯಾಕೆ ಈ ತರನೇ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂದ್ರೆ, remember, even a single point changes, of course you are going to get the different options within this range itself. They could have given 0.02, 0.05, but they have not given. Why? Because competitive exams are in such a way that they are making use of your brain. They want to test that how your brain works. In a single point change ಆದ್ರೂ ಕೂಡ of course ನಿಮ್ಮ ಪಾಯಿಂಟ್ ಏನಾಗುತ್ತೆ, ನಿಮ್ಗೊಂದು ರಿಸಲ್ಟ್ ಬಂದೇ ಬರುತ್ತೆ. ಆ ರಿಸಲ್ಟ್ ಈ ಆಪ್ಷನ್ ಅಲ್ಲಿ ಇದ್ದೇ ಇರುತ್ತೆ. So you will go and tick that wrong option. So you should be very much particular whenever you are shifting your points or dividing certain things. Is that okay? Similarly here also, can you see 20, 0.25, 2.5, 25. And the range is same. So you should be very much particular about your point shifting or division part. So let us go on. So 100 ml ಕೊಟ್ಟಿದ್ದಾರೆ, ಓಕೆ ವಾಲ್ಯೂಮ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ನಮಗೆ milligrams ಅಲ್ಲಿ ಕೊಡಬೇಕಿತ್ತು, ಅವ್ರು ಏನ್ ಮಾಡಿದ್ದಾರೆ ನಮಗೆ grams ಅಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ. They have given in grams. So what you are going to do now? Let us convert first this grams to milligrams. What we know, 1 gram is equals to 1000 milligrams. So 0.25 grams means 0.25 into 10 to the power of 3 grams. Okay, you have written it. So volume of the solution, colloidal solution is 100, yes, into 10. So of course what I'm going to get as an answer. So here 2 goes, here also 1, 2. So I'm going to get as what? Overall the gold number is equals to 25. Remember, gold number doesn't have a value. Sorry, so gold number doesn't have a unit. Sorry for that. Gold number is not having any unit. What is the gold number? It is just a numerical value. Okay, 25. Yeah. So now what will be your option? It is your D. So by this way, we can easily calculate the gold number using its particular formula. Is that okay? Very good of that. So in our today's video, we have understood one important, most important concept is what? How to prevent the coagulation of your lyophobic colloids. Why we are mainly concentrating on the lyophobic colloids? Because it itself is less stable. That is the reason. Lyophilic colloids are somewhat more stable, so there is no need. Bari electrolyte hakadre lyophilic colloid ige enagutte ನಾವು ನೋಡಿದ್ವಿ, it will not undergo coagulation because it is having one surrounding water of hydration. But when you are coming for the lyophobic colloid, it is not such a criteria. It can be easily coagulated if electrolyte is present in it. So in order to prevent this coagulation, what we saw was we can add the lyophilic colloid. So lyophilic colloids are called as what? Protective colloids. Why? Because they are forming a protective layer around your lyophobic colloid, which doesn't allow the electrolyte to come in contact with that of your lyophobic colloid. When the electrolyte itself cannot come and cause the neutralization of your lyophobic colloidal particles charge, coagulation does not occur. So that is the reason we are calling your lyophilic colloid as that of your protective colloid. But when we are seeing such examples of your lyophilic colloids, we are having many such examples. It could be your starch, gelatin, hemoglobin, gum, all those things. When the question arises that how much amount of your lyophilic colloids has to be added in order to prevent the coagulation, so that important tendency was being done or calculated using your gold number. And we came to know that what is your gold number? Basically, it is a number in milligrams which has been required as a protective colloid required in order to prevent the coagulation of your lyophobic colloids. Yes, when how much amount of your standard solution you have to take? A standard solution of your 10 ml of your gold salt, and we are adding an electrolyte of 1 ml of your 10% NaCl solution. So in a standard system is maintained. So our standard system ಗೆ ಎಷ್ಟು milligrams ಹಾಕಿದಾಗ ಅದು coagulate ಆಗೋದಿಲ್ಲ, ಅದನ್ನ ನಮ್ಗೆ ಏನಂತ ಕೊಡುತ್ತೆ? our gold number. And we came to know what your gold number is inversely proportional to your protective power. That means what? Higher the gold number, its tendency to protect your lyophobic colloid decreases. So lesser the gold number, its tendency to protect your lyophobic colloid increases. So now of course we came also with a formula, that is gold number is equals to number of milligrams of your lyophilic colloidal salt added divided by volume of the solution in ml into 10. Why this 10? Because whatever the colloidal system we are taking, yes, the lyophilic colloidal system, it is what? Sorry, lyophobic colloidal system, it is 10 ml of your gold salt. Lyophobic is colloidal system, 10 ml of your standard gold salt. Since that is the reason we have chosen over here as 10. So idunnu ittukondi ಏನು ಮಾಡ್ತೀವಿ ನಾವು? We are seeing that how much number of the milligrams of your lyophilic colloidal salt is required and how much amount of the solution we have taken, that is in ml. So taking that one, when you're substituting your proper values, you can easily calculate any of the three quantities. You can either calculate your gold number or that of your milligrams of your lyophilic colloid or even in your volume of the solution. But do remember, if any two quantities are given, the third quantity can easily be found out. So that is the reason it is an easy calculation and very much important concept to understand which is your protective colloid and which colloid you are protecting. So remember, your protective colloid is a lyophilic colloid. Why? Because it is having a property. It is having a property of what? Protecting your lyophobic colloid by forming a protective layer around it. Yadrinda protect ಮಾಡ್ತಾ ಉಂಟು? Basically in the presence of your electrolytes. So that is the reason your lyophilic colloids, again and again I'm mentioning, your lyophilic colloids are called as what? Protective colloids. And from which colloid it is getting protected? That is, it is protecting your lyophobic colloids. Yadrinda protect ಮಾಡ್ತಾ ಉಂಟು? From your electrolytes. Is that okay? So in our next video, we will be able to see an important noteworthy concept called as it of your emulsions. Of course, we have seen alva emulsions and the namage gottu when we were seeing the classification of the colloidal particles. But somewhat in detail, we will be learning about emulsions and that of your applications of your colloids. Okay.